นะครับโอเค
Okay, good afternoon to everyone. I'm Cheng Yang, and today I will be presenting about an overview of name entity recognition. So name entity recognition is a part of a bigger picture, which is the information extraction field. Information extraction is the process of extracting structured information from unstructured machine readable documents. For example, the source document will be served as an input to the processing steps to normalize the text, and then pass to the name entity recognition to identify the name entity. Then after that, utilizing the information, you can do whatever you want with the entities. For example, that one is to take out the Elvis and classify it as a person and the date. Okay, what is name entity recognition? Name entity recognition is a subclass of information extraction that aims to identify which snippets in the text mentions of entities in the real world. It will extract the entity from text and classify the entity into their respective classes, which the common classes will be person, organization, location, and miscellaneous. However, some people would prefer to further break down into money, percent, date, and time, and there are also other entities which you can customize it based on your own needs. Name entity recognition is used to extract the who, where, when, and how in a sentence, which we can see in the common chit-chats in our daily life. For example, where does the bombing incident happen? The answer type will be the location, and when will be the next stop? The answer type will be the date, and who is the first Malaysian astronaut to do a spacewalk, and the answer type is person. So, in fact, most of the answer to a question is usually a name entity, and just in case I notice, name entity are usually noun phrases. So, here's an example of how name entity recognition works. So, this is the raw document, which serves as the input. Then, the name entity recognition will recognize the words that entities that we are interested, which is in this case is the date, the disease name, and the location. And after you recognize the entity, then you will be recorded down into for various usage later on. The application of any name entity recognition is all around us. Actually, for example, is iMessage. For those who are using iPhone, I'm pretty sure you already know about this function where you send a text, then you will recognize it. Some of the portion of the text is a phone number or date in this part. Which is the date, and some of them the URL. The underlines are the original screenshot taken from the iMessage. They can recognize the entities. Then, according to their classes, different entities will evoke different response when you tap on it. For example, for the phone number, you tap on it, it will ask you for do you want to get context or call. Then for the time, they will ask you want to put in the calendar, or you want to invoke a browser to go to the web page. Then the background of the NER. In the old days, traditional NER system was designed to use in long text like documents, articles, books, and other different kinds of articles. And these documents are all well structured, have good grammar, and have a proper use of capitalization. Thus, for these kinds of documents, the NER system have already achieved 85% to 90% of accuracy. However, when the traditional NER systems are applied onto those micro-block text, or what we call microtext, which is kind of like SMS, those short text, accuracy drops to 30 to 50%. Why is this so? Because NER is a sequential labeling task which utilizes the contextual clues to label the entities. This will be discussed later on in the slides. And the traditional NER also relies on heavy capitalization. So, internet-related text type of text are short, less grammatical, and contains unorthodox capitalization and contains other noises like hashtags, abbreviations, emoticons, like something like this, which doesn't work well with the traditional entity recognition systems because these are not a common word like this. So these animals are considered as noises that causes the performance of the system to drop, and in the current trend, researchers are focusing on solving these kinds of problems to work on those micro-block text. So the NER system only performs well. It is claimed that NER system only performs well in the domain where it is trained. Like for example, if I design this system, NER system to work for the law documents, when you apply it on medical documents, it doesn't perform as good as the law documents data sets. NER systems accuracy will drop if it is encountered entities that haven't seen before, because for NER systems, some of the approaches which we rely on a very large training data set. So if some of the entities are not well prepared and the amount is not that much, the NER system will unable to classify the entities. And one of them is as mentioned just now, the entity systems, NER system doesn't work well on IRC checks. So there are a lot of existing tools that offer functionality of NER system, and one of them, the biggest one, has proven that they have a very high percentage in getting the filter type of text, filter text recognizing entities in filter. For those who don't know what F1 measure is, this is the formulas. And NER, standard NER also is a very state-of-the-art NER system. So these all are the highlighted ones, and there are also obviously more of the tools. So
maybe it's good to share what the TP, TF. I think you said it's a formula, but what's that?
Okay. For TP is the F1.
I mean, F1.
Okay. For the TP is true positive, and FP is false positive, and FN is false negative. So after getting this one is the precision. How we get the precision from the true positive and false negative, false positive? Before you get from this formula, then after that you come inside this formula to get the F1 measures. Okay, from the table we can see that for NER, the main approaches that will be used are machine language approach, rule-based methods, and Gaussian lookup. For those who don't know what is Gaussian lookup, it's basically a list of words inside a dictionary and run keyword search. Lately, machine language has been widely adopted.
machine learning.
Machine learning have been widely adopted, especially for sector as SPM and CRF. However, each of the methods have their own pros and cons, which we will be talking later. So before that, I would like to talk about features. For features in words, they are different from what we think it is. Descriptors are characteristics as attributes of words are designed for algorithmic consumption. Then the features can be classified into word level features, list lookup features, document and corpus features. Usually we only concentrate on word level features, which looks at the capitalizations, the format, how the name are written in, like RD, junior, dot, all those features that we are looking at, how the digits are written in. And for rule-based, the NER problem is resolved by applying a rule system over these features that collected. For machine language, the features will serve as the input and to infer the entities and machine learning.
Yes.
For the preprocessing steps are crucial for the performance of the name entity recognition system, as it will clean up a lot of noises. Depends on one designs, different combination of preprocessing steps would be taken, and these are the common preprocessing steps that have been used. Tokenization, which splits the sentence into individual words. Some of them, tokenization differs from system to system. Some of them likes to split out the comma. Some of them just combine it together with the words. And part of speech tagging, which gives the text to each of the words, which is like noun, verb, adjectives, and others. Shallow parsing is the combination of multiple words together to form a phrase. Usually, it uses the clues from based on the PSS text. Something like Barack Obama, it should be a word, so you will put it together and become a noun phrase. Then normalization is process of transforming text into a single standard form, which is easier to be processed. Then some of them also use the stemming process, which is to reduce the connected words into their root form. So, how NER works? NER is basically a sequential labeling task which assigns name entity text into each word, which they commonly use the scheme of BIO or BILOU, which stands for beginning of the text, inside of the text, which is the continuation, outside of the text, the last word of the text, and the units. For example, for this entity, when you reach this part, it will detect it as beginning of the entity, so it's beginning of the location entity. Then inside of the location entity, and inside of the location entity, this one is outside. So this one will be detected as a location entity from the text.
But you're only doing location, right? So anything else is not location is considered outside.
No, this one is just a center.
Okay.
There are a lot of
Okay, let's have organization also.
Yeah, B organization, B miscellaneous. So machine learning. For the machine learning, it utilizes the features to infer whether it is or not an entity. By features, I mean the features of the words in the surrounding. The features input differs from different systems according to each design. These are some of the basic features like POS text, the position of the visualization of the words. After, there are a lot of other features which can be used. After obtaining this information, the system will calculate the probability of each word respective to each class. So, for example, the Barack in the recent years, Barack Obama has, for this entity, calculate the probability, the score, and the highest score will serve as it will be tagged as, the Barack will be tagged as the beginning of the person entity.
This probability calculation is just one of the methods, right?
Yeah.
I mean, not necessarily, I mean, not all methods do the same way, right?
Yeah, but this is the common one.
Common one.
Yeah. For this one is a more clearer picture. For example, when we are at this the first word, let's say the window will be the 4 words around it. It starts with, then you will generate feature according to the words surrounding. JP is a noun, capital letter yes, the position, and other different types of features which is not written here. Then after you get everything, the next words features, the third words features. After that, you will plug into the machine learning, then you will infer the score, and the highest score will be this one will be DAT will be tagged as the beginning of organization words. And for the next one, like when we are here, Lim, and you will also generate get the features of the words in the surrounding, then the highest score will be 10. This is just extra example. Okay. For rule-based, what are rules? Many of the real-life extraction tasks can be conveniently handled through a section of rules, which this will give a transparency of the systems. In general, the rule-based system consists of a collection of handcrafted rules and a set of policies to control the firing of multiple rules. Because in a sentence, they may trigger a few types of rules, so you need to have control the firing of the rules. Here are some examples of the rules. Now you can see what I mean by the transparency. Is easy to understand, read and understand. This one is like the pseudocode for the rules. If the text before the semicolon is not a number, then it is a location. If the text after at and it is a noun, it is a location. These are the pseudocodes, and this one is the sample code for how the rule base looks like. So it will detect for this certain rule to detect company. If the words are in a higher upper initial, then it will look up the company, the dictionary, and detect the pattern. Then if it's matched, then the word will be categorized as the company. So some of them utilizes trigger words. Trigger words for this example is add. So it uses the left context, the filler, and the right context. So at the word beside the add, and the next one is the auxiliary words. This one will be tagged as the I. So for the Gassendi approach, one of the most common questions that people ask or think when it comes to NLP recognition is they will ask why not just do keyword search, which is referred as a Gassendi approach now. Well, it is undoubtedly the most straightforward method among them, and it has the highest precision and accuracy. So what is the problem? So it will work well for formal text that doesn't have a lot of spelling problems. And however, for the entities that is not recorded in the dictionary, it fails to detect them. And the disadvantage is it can't cope with the expansion of words because every day there's new words added inside our dictionary, not inside the dictionary. Different words coming up, and even for locations, there are different locations adding in. And potential sets of name entity is too large to include inside the dictionary. This depends on which domain you are doing it, because if you want to do it generally, there are a lot of words to be added, so it is too large. And names are changing constantly and appear in many variant forms. So this is the summary of the approaches. So for machine learning, the advantage will be is trainable, adaptable, and claims to reduce manual efforts. However, if it requires large training data sets, which is very consuming, and requires manual annotation of data and is opaque, which means you can't, if you encounter a problem, you will be highly not likely to find out what is the problem from the data sets. So for rule-based, the advantage is it is easy to comprehend and maintain and to incorporate domain knowledge, and it's very easy to trace and fix the errors because the example I showed just now, the rules are quite readable. So if you see which you can trace back to the original rules that causes the certain problems. However, the disadvantage is it requires manual handcrafted rules, which we need to go through the data sets to get to know the rules, to formulate out the rules. For the Zapier is very high precision, but it is able to keep up with the expansion of the vocabulary and tolerable to spelling errors and annotations, which will not work well for the micrograph text. So when we talk about these approaches, we often compare machine language to rule-based. In the recent years, most recent academic research starts from the assumption that machine learning approach is the best approach for solving information extraction problem. And from the graph, you can see from 2003 to 2012, only 6 papers rely solely on rule-based is published. However, if you see in the commercial world, the things are totally different. Dominant ones are rule-based, using rule-based methods. For 54 vendors that they have protected, there are 46% of them that use rule-based, and for the large vendors like IBM and others, there are 67% of them are using rule-based methods. So, what is the source of disconnection? Academic papers evaluate information extraction performance in terms of precision and recall over standard label data sets. However, in reality of the business world, it's much fluid and less well defined. In business context, IE must function well with the metrics that are ill-defined and subject to change, because every company has different definition for each of their, even for product, for different companies they have their own different definitions. So machine learning based models requires a careful upfront definition of IE tasks which will fit poorly inside these kind of situations. And rule-based model is preferred for its interoperability, which makes it easier to adopt, understand, and maintain. So however, when people will say that when it comes to rule-based, it is tedious and time-consuming, and it's not really practical, because we need to go through all the data sets to get the rules, to formulate the rules. However, machine language also have tasks that requires often ignored. And tasks are like defining the business problem to be solved in mathematical terms, understanding the trade-off between different types of models, performing feature engineering based on a solid working understanding of the chosen model, and gathering extensive behavioral data. These tasks, all of them each also require a lot of time. So in short, in commercial work, machine learning-based systems are often deemed to be too risky to adopt, difficult to understand, and opaque. And one of the extra reasons is the invisibility of very labeled data in the real-world scenarios.
Which is better? So in the end, which is better? I was using this a bit.
Both of them depends on what is the situation where you want to use. Of course, if you have the resource to do that, you have the manpower. Machine language, and if you want to use it in a specific domain only, machine language. Machine learning
maybe the commercial software and products, they have a very specific kind of domain, so therefore they can actually get some what we call create expert system, get people to find the rules, put it out, and it works. And very rarely you get outlier because everything is within the same domain. But if you're creating an app or something which the general public is going to use, I mean, the data is going to come from everywhere, then maybe machine learning might be a way to go. But it's a very researchy kind of academic kind of thing. But you can create more powerful stuff that cater to more generic situation. That means you're just going to analyze Twitter messages from any kind of source. Then maybe machine learning can learn a lot of things. But if you're analyzing this Twitter data for traffic, for example, then maybe inventing some rules relating to location and person might be better. That's what I think.
Just now you have some papers on IRC, right? And you have one paper that's on Twitter. Do they not have many people doing this on Twitter? Right? Do they? Are there not many people doing NER on Twitter?
You mean this one?
There's only one. This one using Twitter. Right?
There's two more here.
What did they use? The guys that use Twitter, what kind of method did they use?
This time we are using machine learning.
Machine learning. But what is the domain? Is it just anything and not just traffic?
It's very general.
I see. So it's general is good for it's good to go for machine learning. But if you want to have high accuracy, then maybe you have to invent rules. But some people don't like that because that's very heuristical. Companies want that because they want performance.
Your work is very specific.
Yeah, so maybe rules might be enough, but I'm not sure whether rules such thing rules. Okay.
Rules first.
Rules first.
Forget this.
It's for expert system. Expert system.
NER.
How do you handle short form? In Twitter, it's going to be a lot of short form. Especially Malay. It's a lot.
There's actually different methods to do that because one of them manually go through the tweets. Not manually go through the tweets because usually short forms they are small, shorter than 4 characters. You can extract them all out and try to translate them. There are also resources on the internet that have their own Malay translation for the information.
Maybe you create a large lookup table to translate all the short forms to long form, and then everything can process as you go.
For each word in the lookup table, you can store all the variations like short form, like for example, the thank you is like GQ,
Yes.
TH.
But I think Malay is quite complex.
You might need. No language. the short form T.
But that's quite easy, but another difficult one is like when you say takde, they put an X, this you can't translate that, it's more like a prefix. Because it can be X something else, because it's not X the only, it's X something else.
That's okay. The SY is worse.
Oh, SY, yeah.
SY has multiple meanings.
Messiah can be Sayo, so
Saya.
SYG.
But it's also okay, like because each language it's going to have so many number of words, like maximum maybe 10,000
Malay has quite a lot because of the different dialects and different countries.
Yeah, if you go north of Malaysia, it's a bit different. Yeah, this
Yeah, basically 13 different dialects.
Logat.
Then out of 9 it's also okay for computer, like it can do that's the answer.
But it's okay because for him, he doesn't need any of like he just throw away those things. He only needs the entity.
Maybe you constrain your filters with the nice ones.
It's not important what they mean.
Scope a bit.
She says trying to do things, location as well as state. Like you stated.
Oh yeah.
So it's not only the location.
No emotion.
But the one is quite difficult to.
It's quite new. It's quite new. Emotion between.
Not the emotion thing, but emotional phrases.
Yeah.
Not the emotion.
Emoji is a totally different thing.
Emoji is completely different.
And the one you can consider this contextual.
Anjo. Tapi kan.
But again, there's sarcasm sometimes.
Extracting the location from Twitter and Instagram, it could be applied using the API.
And can you say the answer?
I'm not analyzing the text, the context. For extraction of the location.
That's why usually look up to extract the information first. Because if you send to any of this Azure cloud or whatever not, it doesn't have enough text for it to extract. Yeah. It's too short. Some of them are like 6 words.
Have you thought about how typos should be dealt with? I know I'm asking a lot of difficult questions. but it's good to think about the good questions. Just helping you think about
the assumption that mostly text work, right? You make the assumption that typo is not, they don't handle typo, basically spelling errors.
Then you won't be real.
Because even that's a spelling correction, it's also a special.
Oh, yeah. So you can pass it through a spelling correction first, then you pass it through the long form, then pass it through the spelling correction.
Sometimes the short form after the spelling correction,
you change it.
For example, the ADY, it comes a day.
So there will always be a manual intervention.
This ADY already.
Yeah, but if you go to the spelling correction, it comes a day.
Yeah, but Malaysian is not like Malaysian OLEDI.
Already.
That ALDY is very American. You never use that. This F1 measure is how you can measure it.
Should be.
Is it used by most papers?
Yeah. For this NER papers.
I don't know what they call it recall.
Because how many you retrieve? Recall.
Decision recall. Thank you all for coming. There's coffee, there's biscuits.